When civilizations lose sight, how complex systems begin optimizing measurements instead of reality. Summary statement. Complex civilizations cannot directly observe their complete internal state. They therefore rely on proxy metrics to infer the underlying condition of the system. As institutions mature and reality evolves, those proxies gradually become decoupled from the outcomes they were originally designed to measure. Governance then begins optimizing the observable metrics rather than the hidden reality itself. The resulting divergence explains how civilizations can report success while simultaneously becoming less productive, less resilient, and less aligned with their original purpose. Section 1. Introduction. The hidden constraint. Every civilization faces the same fundamental problem. Before it can govern itself, improve itself, or even survive, it must first answer a deceptively simple question. How healthy is the system? At first glance, the answer appears obvious. Measure economic growth, measure inflation, measure unemployment, measure education, measure healthcare, measure military strength, measure national wealth. Modern civilization is awash with numbers. Yet despite having more data than any civilization in history, many societies appear increasingly uncertain about their own condition. Housing becomes less affordable while property values reach record highs. Healthcare spending reaches unprecedented levels while public health often stagnates. Defense budgets continue expanding while recent conflicts raise new questions about operational effectiveness. Financial markets set new records while productivity growth remains subdued. These are not isolated contradictions. They suggest something more fundamental. The central proposition of this paper is that complex civilizations eventually encounter an engineering problem rather than merely an economic or political one. They gradually lose the ability to distinguish between the measurements describing reality and reality itself. The consequence is subtle but profound. Institutions begin improving the numbers that are supposed to represent success instead of improving the underlying conditions those numbers were originally intended to describe. The civilization appears healthier on paper. Meanwhile, its underlying condition may quietly deteriorate. This paper argues that this transition is neither accidental nor unique to any one nation. It is an inherent risk whenever increasingly complex systems must govern themselves through indirect observation. 2. Observability and reality, the engineering problem. To understand why this happens, we must begin somewhere unexpected, not with economics, but with engineering. Every control system follows the same fundamental sequence: observe, decide, act. The quality of every decision depends upon the quality of observation. If the observations are inaccurate, delayed, or misleading, then even perfect decision-making will gradually steer the system away from its intended objective. This principle is universal. An aircraft cannot fly safely if its instruments no longer reflect its true position. A doctor cannot treat a patient accurately if the monitoring equipment no longer reflects the patient's physiological condition. A factory cannot optimize production if its sensors no longer represent what is actually occurring on the production line. The challenge becomes considerably more difficult when the system itself cannot be directly observed. Engineers describe these as partially observable systems. The internal state exists, but it cannot be measured directly. Instead, it must be inferred through observable signals. Medicine provides a familiar example. A physician never directly observes health. Instead, they observe heart rate, blood pressure, oxygen saturation, temperature, blood chemistry, and electrical activity. None of these measurements are health itself. Each is a proxy, a measurement intended to infer an underlying condition that cannot be observed directly. Economics presents an even greater challenge. No one has ever directly observed the economy. The economy is not a physical object. It is an emergent system arising from billions of individual decisions, transactions, investments, expectations, and exchanges. Consequently, governments and institutions rely upon indirect measurements. Gross domestic product, inflation, unemployment, house prices, interest rates, market capitalization, consumer confidence, government expenditure. These are not the economy. They are attempts to describe the economy. That distinction is crucial because it means that governance is fundamentally an exercise in inference rather than direct observation. The challenge is therefore not that civilizations rely upon measurements. The challenge is that they must continually ensure those measurements remain faithful representations of the reality they were designed to describe. Section 3. The birth of proxy metrics. The existence of proxy metrics is therefore not a mistake. They are an engineering necessity. Every sufficiently complex civilization must compress an almost incomprehensible volume of information into a manageable set of indicators that policymakers, businesses, and citizens can understand. GDP, inflation, unemployment, defense expenditure, educational attainment, and healthcare statistics were all developed for precisely this reason. They serve as instruments, like the gauges inside an aircraft cockpit. Originally, these measurements often exhibited a strong relationship with the underlying phenomena they described. Industrial output closely tracked GDP. Defense expenditure generally translated into increased military capability. Housing prices broadly reflected supply, demand, and economic prosperity. Healthcare expenditure often accompanied genuine improvements in medical care. Education budgets frequently expanded alongside literacy and workforce development. The instruments were not perfect, but they were sufficiently well calibrated to reality that improving the measurement usually meant improving the underlying system. This relationship is the foundation upon which modern governance was built. The measurements functioned because the measurements remained coupled to reality. The danger emerges only later, not because the measurements become inherently wrong, but because reality itself continues evolving while the instruments used to describe it remain calibrated to an earlier world. At that point, the civilization unknowingly begins navigating with an increasingly outdated map. The instruments still function. The numbers continue arriving. The dashboards remain full, but the relationship between the measurement and the underlying reality has quietly begun to weaken. That weakening, the gradual loss of calibration between reality and its measurements, marks the beginning of what this paper will describe as proxy drift. This content is brought to you by Bobby Giggs. Promote your brand here and reach a wide audience across platforms like YouTube, Instagram, and Facebook. Follow the links in the description to get started. Section 4. The calibration problem. When reality evolves faster than measurement, every measurement system is calibrated to a particular reality. A thermometer is calibrated against the physical properties of temperature. An aircraft's altimeter is calibrated against atmospheric pressure. A speedometer is calibrated against the rotation of the wheels. As long as the relationship between the measurement and the underlying reality remains stable, the instrument continues to serve its purpose. Complex civilizations operate under exactly the same principle. GDP was calibrated during an era in which industrial production dominated economic output. Military expenditure evolved during an era where industrial capacity, large standing armies, naval tonnage, and air superiority closely correlated with battlefield effectiveness. Housing prices emerged as a reasonable approximation of housing demand and economic prosperity. Healthcare expenditure often accompanied genuine improvements in medicine. Education spending broadly reflected investment in human capital. Initially, these relationships were sufficiently robust that improving the metric generally meant improving the underlying outcome. However, reality does not remain static. Technology changes, demographics shift, institutions mature, incentives evolve. Financial systems become increasingly sophisticated. New forms of competition emerge. Global supply chains become more interconnected. Artificial intelligence begins reshaping production. Warfare transitions from mass industrial conflict toward distributed autonomous systems. Reality evolves continuously. Measurement systems evolve only occasionally. This asymmetry introduces an unavoidable engineering problem. The measurements themselves may remain internally consistent while becoming progressively less representative of the world they were originally designed to describe. The calibration slowly expires. Nothing appears broken. The numbers continue arriving. Institutions continue reporting success. Yet the relationship between measurement and reality quietly weakens. This is the beginning of calibration drift. The instrument is still functioning. It is simply measuring yesterday's world. Section 5. The proxy drift sequence. The consequences of calibration drift follow a remarkably consistent sequence. Although the examples differ across economics, defense, healthcare, education, and technology, the underlying process appears strikingly similar. Stage 1, reality and proxy remain tightly coupled. The measurement faithfully reflects the underlying system. Improving the metric genuinely improves reality. Stage 2, reality evolves. Technological change, institutional maturity, demographic shifts, financial innovation, changing incentives, the underlying system begins changing. Stage 3, the proxy remains largely unchanged. The measurement continues to be used because it has historical legitimacy. Policies continue referencing it. Institutions continue reporting it. Governments continue targeting it. No one notices that the calibration has begun to drift. Stage 4, institutions begin optimizing the proxy. Because the proxy is observable and the underlying state is not, decision-making increasingly rewards improvements in the measurement itself. Budgets, targets, performance indicators, benchmarks, league tables, growth figures, ratings, all become objectives rather than observations. Stage 5, reality and measurement diverge. The dashboard reports success. The underlying system becomes progressively less aligned with the reported measurements. This is the critical turning point. Reported performance and actual performance begin moving in different directions. Stage 6, governance begins steering toward the proxy instead of the system. The civilization now governs the measurement, not the underlying reality. Policies become increasingly successful at improving observable indicators while becoming progressively less effective at improving the conditions those indicators were originally designed to represent. This is the point at which proxy optimization becomes self-reinforcing. The more institutions rely upon the metric, the more resources flow toward improving the metric. The greater the investment in the metric, the harder it becomes to question whether the metric still reflects reality. The civilization has unknowingly begun steering toward the dashboard rather than the destination. This 6-stage progression represents the central systems model proposed in this paper. Section 6, Goodhart's Law Revisited. Goodhart's Law is often summarized as, when a measure becomes a target, it ceases to be a good measure. This insight is both profound and widely accepted. However, Goodhart's Law primarily describes what happens. It does not fully explain why it happens. The framework developed here proposes that Goodhart's Law is not the root cause. It is a downstream symptom of a deeper engineering constraint. Complex systems cannot directly observe their complete internal state. They therefore rely upon proxy measurements. As reality evolves, calibration gradually weakens. Institutions continue governing through the existing measurements because they remain observable. Eventually, optimizing the proxy becomes institutionally rational. Goodhart's Law is therefore not the disease. It is the visible manifestation of calibration drift operating under conditions of imperfect observability. This distinction matters because it shifts the focus away from blaming individual policymakers, bureaucracies, or organizations. The actors are frequently responding rationally to the information available to them. The architecture itself increasingly rewards improvements in the observable measurements. The underlying reality receives progressively less attention simply because it is more difficult to observe. The problem therefore lies less in human intent than in the structure of the feedback system itself. Governance becomes increasingly dependent upon measurements whose relationship with reality has gradually weakened. The civilization continues making decisions. It continues collecting data. It continues reporting progress. Yet it is now attempting to control an evolving system using instruments calibrated to an earlier reality. This is the engineering failure. Not that proxy metrics exist, but that civilizations gradually forget they are proxies. Section 7, 3 patterns of proxy optimization. Although proxy drift manifests differently across sectors, the examples discussed throughout this paper appear to cluster around 3 recurring failure modes. Recognizing these patterns is important because it shifts attention away from isolated policy debates and toward the underlying architecture producing them. The first pattern is asset and value distortion. Here, financial representations increasingly replace the productive realities they were originally intended to reflect. GDP becomes a proxy for productive capacity rather than a measurement of activity. Housing prices become a proxy for housing success rather than housing affordability. Technology valuations and AI infrastructure investment increasingly become proxies for future productivity before corresponding productivity has fully materialized. In each case, the financial representation may continue rising while the underlying outcome becomes progressively less certain. The second pattern is cost-plus optimization. Here, expenditure itself gradually becomes interpreted as evidence of success. Healthcare systems increasingly celebrate larger budgets rather than healthier populations. Education systems increasingly evaluate investment levels rather than educational attainment. The measurement shifts from outcomes toward inputs. More spending becomes increasingly interpreted as progress, regardless of whether proportional improvements occur. The third pattern is capability decoupling. Defense illustrates this particularly clearly. Historically, larger procurement budgets generally translated into greater military capability. Recent developments in autonomous systems, inexpensive drones, electronic warfare, precision strike technology, and distributed sensing suggest that this relationship may be changing. The relevant question is therefore no longer simply, how much is being spent, but rather, how much capability is being created per unit of expenditure? The optimization target changes from budget scale toward operational effectiveness. Across all three patterns, the common mechanism remains identical. The observable measurement gradually replaces the hidden objective. The civilization begins optimizing the shadow cast by reality rather than reality itself. This content is brought to you by Bobby Giggs. Promote your brand here and reach a wide audience across platforms like YouTube, Instagram, and Facebook. Follow the links in the description to get started. Section 8, Governance, under Imperfect Observability. At this point, an important clarification must be made. The framework presented here is not an argument against governments, markets, bureaucracies, or institutions. Nor is it an argument that the individuals operating these systems are irrational. Quite the opposite. Most actors behave rationally within the information environment available to them. If a government measures GDP, it will optimize GDP. If a defense department is evaluated according to procurement budgets, it will optimize procurement budgets. If hospitals are rewarded for expenditure, they will optimize expenditure. If universities are rewarded for enrollment, they will optimize enrollment. The problem, therefore, lies deeper than politics. It lies in governance under imperfect observability. Decision makers cannot directly observe the complete state of a civilization. They must instead rely upon instruments. Those instruments become embedded within budgets, legislation, institutions, incentive structures, financial markets, international organizations, and political expectations. Changing them becomes extraordinarily difficult. Eventually, the architecture itself begins rewarding improvements in observable indicators while quietly neglecting the hidden reality those indicators were originally designed to represent. This explains why proxy optimization should not be understood primarily as corruption, incompetence, or ideological failure. Rather, it emerges as a structural property of mature institutional systems operating through imperfect observations. The incentives are internally rational. The architecture has gradually drifted. Section 9. Pax Americana as a case study. The framework developed throughout this paper can now be applied to a contemporary geopolitical example. The purpose is not to prove the framework through one conflict. Rather, it is to illustrate how proxy drift may appear within a real-world system. For much of the post-war period, American power was commonly measured through observable proxies: defense expenditure, aircraft carrier strike groups, advanced fighter aircraft, alliance networks, dollar dominance, capital market depth, global military presence. Historically, these measurements correlated strongly with American influence. However, recent developments suggest that the underlying reality may be evolving. Low-cost autonomous systems have altered the economics of warfare. Energy choke points continue exerting disproportionate strategic influence. Industrial replenishment rates have reemerged as critical constraints. Alliance behavior increasingly reflects domestic economic pressures rather than purely geopolitical alignment. These developments do not demonstrate that the United States has ceased to be the world's preeminent power, nor do they prove that Pax Americana has ended. They do, however, raise a legitimate structural question. Have some of the traditional measurements of geopolitical power become less tightly coupled to the realities of 21st century competition? This distinction is important. The framework does not argue that American power has disappeared. It argues that the relationship between the traditional indicators of power and the practical exercise of power may be evolving. The Iran conflict, the Ukraine conflict, global energy disruptions, AI infrastructure investment, industrial competition, and changing alliance behavior are therefore not presented as proof of decline. They are presented as possible evidence that reality has begun moving faster than the measurement system traditionally used to describe it. America thus serves as a case study rather than the subject of the theory itself. Section 10. Recovering reality. We need our eyes back. If proxy drift represents the problem, what constitutes the solution? The answer is not more metrics, nor is it abandoning measurement altogether. Measurement remains essential. Complex civilizations cannot govern themselves without instruments. The challenge is fundamentally one of calibration. Civilizations must continually ask whether their measurements remain faithful representations of the reality they were originally intended to describe. This requires distinguishing between outcomes and the measurements used to estimate those outcomes. It requires recognizing that no proxy should become immune from re-examination. Most importantly, it requires resisting the temptation to confuse improving the dashboard with improving the underlying system. The objective should never be maximizing GDP. The objective is increasing productive capacity. The objective should never be maximizing healthcare expenditure. The objective is improving population health. The objective should never be maximizing defense budgets. The objective is enhancing defensive capability. The objective should never be maximizing educational spending. The objective is increasing educational attainment. The objective should never be maximizing financial valuations. The objective is increasing productive investment. The metrics remain valuable, but they must remain servants of reality rather than substitutes for it. This is ultimately what is meant by the phrase, "We need our eyes back." It is not a rejection of measurement. It is a call to recover higher fidelity interfaces between civilization and the reality it seeks to govern. Conclusion. Civilizations rarely fail because they stop collecting information. If anything, mature societies accumulate ever greater quantities of data. The danger lies elsewhere. It lies in gradually losing the ability to distinguish between measurements and the realities those measurements were originally designed to represent. Every successful civilization develops instruments to help it understand itself. Initially, those instruments are carefully calibrated. The measurements closely reflect reality. Over time, however, reality evolves. Institutions mature, technology changes, incentives shift, the measurements remain, the calibration quietly expires. Governance then begins optimizing the measurements because they remain observable, while the underlying reality becomes progressively more difficult to see. This paper has proposed that this process represents a general systems phenomenon rather than merely an economic or political one. Goodhart's law emerges not as the fundamental disease, but as one visible symptom of a deeper engineering constraint. Complex civilizations must govern themselves through imperfect observations. The central challenge is therefore maintaining calibration between observable metrics and the hidden realities those metrics were created to estimate. This transforms the discussion from one about economics into one about observability itself. The ultimate question facing modern civilization is no longer simply, how should we govern? It is, how do we know that what we are observing still faithfully represents reality? Only after answering that question can governance hope to optimize the system itself rather than merely the shadows it casts. Because every proxy begins life as a faithful measurement of reality. Proxy drift begins the moment reality changes faster than the measurement system used to describe it. And perhaps the defining challenge of the 21st century is not simply building better policies. It is recovering the ability to see.